does the lower cost of wind energy play into the choice of it, or to see it percolate towards the top? Is it really based on pricing? And natural gas is relatively cheap and stable, of course.
For you.
But wind, well,
For
in the
the
United
United
States, it is. Yeah, some parts of Europe.
Yeah, I know all the European listeners are like,
At the
what?
moment, yeah.
Yeah, that is not an accurate way to describe what's going on with gas at the moment.
Welcome back to the Uptime Podcast. I am your co-host, Alan Hall, here with the Queen of Composites, the Doctor of Blade De-icing, Dr. Rosemary Barnes. We have a great show for you today. We have a number of updates about the U.S. energy. Wind power is gradually increasing in terms of the percentage of power in total, which is really awesome. We had some blades fall off a wind turbine off the coast of Denmark. We'll talk about that because Rosemary's a blade expert. She hopefully provide some insights into what happened there. We also have an interview with Harriet Green of Equinor, who is working on Empire and Beacon Wind offshore wind projects and off the east coast of the United States. So it's a really good interview. Stay tuned for that. Then we talk about some blade aerodynamics, how the seagull feather system is being implemented on wind turbine blades. And I'll ask Rosemary, does it even work? And then there's a really cool project out of Australia where they have a crane where they're using gyroscopes to control the loads so that the wind turbine blades don't blow around. Sort of cool tech. So let's get started. U.S. energy hits a major milestone. That U.S. wind industry had its second highest source peak electricity since we've been gathering data on it. The wind turbines in the U.S. generated 2,000 gigawatt hours of electricity, edging out nuclear and coal. There you go. But still falling behind natural gas. Natural gas in the United States is a huge energy source. Overall, last year, this is 2021, wind energy was the fourth largest energy source behind natural gas, of course, coal and nuclear. But wind generated 380 terawatt hours for the entire year. So a terawatt hour is a lot of energy. Rosemary, do you think, as you see wind energy start to peak up in the United States, do you think that wind energy will become the number one electricity source for a significant amount of time?
Ooh, I don't know. I see most people, I think that solar is going to dominate because, it's cheaper and it's getting cheaper faster. And I mean, the obvious disadvantage with solar is that it doesn't make any energy when it's nighttime, which happens every single day. But battery storage and other kinds of energy storage are also getting cheaper. So I'm usually having the opposite argument with people who say, "Oh, it'll all be solar. There'll be no place for wind in the future. You're in the wrong industry." And I am working with solar as well, so I think I've got my bases covered. But I definitely think that you're not going to see one technology win. It felt like that. I know, like 10 years ago or so, we were really closely watching what was happening with solar because wind, had the lead. It was a cheaper and more mature technology 10, 20 years ago. And people were a bit nervously watching the price of solar fall so dramatically because, I mean, you can obviously extrapolate from that and get to the point where you're like, well, solar energy is going to be free. Essentially, it'll go down to the cost of the glass and aluminium that's in it. But I think now everyone's aware that when you start to integrate really large amounts of variable energy in the grid, then diversity is key, and so it's not going to be a matter of one technology winning over the other, and it's not just like diversity of technologies, it's also going to be geographic diversity. So you're going to see wide areas connected together. So yeah, obviously solar gets a lot more useful if you've got a grid that has a wide east to west span because you've got more daylight hours during the whole grid.
Right.
And wind patterns vary from place to place. So that's why, offshore wind is more expensive, but it can in a lot of ways be a lot more valuable than onshore wind if it correlates, if there's a negative correlation with other variable renewable sources.
Right.
Yeah. So it's interesting to see how it's.
Yeah, just looking at the numbers here. Well, the numbers here are really interesting for this particular day in April. Wind generated about 10 times as much energy as solar. So that's really interesting because I would agree with you that you would think that solar would be your primary low-cost lowest cost energy source, but maybe just because there's so much more wind and a major part of America is windy, it may not be as sunny. Maybe that's what it is. That we're seeing a lot more energy generation by wind, which I think it's unusual. But does the lower cost of wind energy play into the choice of it, or to see it percolate towards the top? Is it really based on pricing? And natural gas is relatively cheap and stable, of course.
For you.
But wind, well,
For
in the
the
United
United
States, it is. Yeah, some parts of Europe.
Yeah, I know all the European listeners are like,
At the
what?
moment, yeah.
Yeah, that is not an accurate way to describe what's going on with gas at the moment.
Yeah, true. Okay, I will grant you that. But in the United States, natural gas hasn't been such I've seen wide fluctuations, of course. But as wind gets lower and lower in cost, don't you see that it's just going to keep climbing the amount of energy produced by it because wind is cheap?
Yeah, and it will, compared to the fossil fuels or anything where you've got to pay for the fuel, then wind is only going to, be more and more competitive or, replace. And I think the key thing is as well, gas is a really flexible generation technology. So
Right.
that's why it's still in the game, despite having to pay for fuel, because you can use it when you need it and not when you don't. So it'll hang around a lot longer than coal, for example, where it's you're kind of stuck with it on. If you want to have it on in the evening, then you need to have it on in the middle of the
Right.
day, even if electricity prices are negative. So that's why, like in Australia, we're seeing coal power plants closing sooner than expected, and that's just going to happen all around the world, is my expectation.
Yeah, so the capitalist system is going to work at some level, right?
Yeah, it's really funny.
Lower cost means more of it.
Because I do see that in Australia, our energy transition is so interesting because, we've been laggards on climate action the whole time that, anyone's been paying attention. We've been, our politicians have, for the most part, just been trying to find loopholes and, all of our emissions reductions to date, practically, or the vast majority of them, have come through just clearing land slightly less fast than we used to clear native forests. So it's not exactly something to brag about, but our politicians do brag about it, about our amazing emissions reductions. And I always think, if only we'd had the foresight to just clear a lot more land, native forest in the 90s, then we'd be doing even better by now, because, it would be an even bigger reduction. But that said, we have what I think is the fastest energy transition at the moment, and I'm not like some like diehard capitalist or anything. I kind of like accept that this is a pretty efficient way to work, and that it's the system we've got that's kind of describes my love for capitalism. I'll tolerate it, but it has our electricity market is quite free and open, and it has allowed the better technologies to take over faster than it has in countries where it's really centrally controlled. And I know a lot of the US grids are like that. They're centrally controlled, and there's like a government operated or government controlled monopoly, and they're very conservative, and they don't just let things happen fast. So so in this case, I do think for the electricity grids, a large part of decarbonisation can be solved by, just making sure that the market is free to choose the best technologies, because, engineers like us have gotten us to the point where those technologies are just cheaper.
So one of the big efforts in the United States is offshore wind, obviously. And we're following the lead of many European countries on offshore wind. Over the past roughly a week or so ago, one of the offshore wind turbines off the coast of Denmark, at the largest wind facility off the coast of Denmark, and I guess the third largest offshore wind facility in the world, in Anholt. And I don't know where Anholt is. I know it's a little island off the coast of Denmark. And have you been there before, Rosemary? Have you been up that way?
No, I'll just look it up on a map, and then I'll see where it is.
Okay. It's a huge facility. It's one of Ørsted's 400 megawatt Anholt offshore wind farm, and they're investigating an incident where a turbine lost 3 of its blades, and it sounds like the rotor fell into the water. Now there's 111 wind turbines on this farm, so it's a massive farm. So losing one wind turbine made no difference in terms of power output for the most part. But obviously, it became a real safety critical event, and there seems to be a lot going on just trying to figure out what happened here. Rosemary, I mean, how else do you lose 3 blades simultaneously without losing the hub and the rotor? It seems like it has to go together somehow.
Yeah, I think so. If they didn't all fall together, then you would have also seen the tower collapse. You would expect, like, if you get an unbalanced rotor spinning around, then that's very quickly going to cause problems for every other part of the wind turbine. So if it was just the blades falling off, then it must have also included the hub. I would suggest, because they must have all fallen off at the exact same time.
Okay, so that was my thought too, that this is not a blade issue as much as it is a hub rotor issue. Somewhere in there had have been the issue. And I guess it raises the question about wind turbine maintenance. Offshore is so much more difficult than onshore, and we're still developing all the techniques and all the safety protocols and the routines of inspecting wind turbines. Now, this wind turbine farm, I think, started in 2013, so it's going on 9-10 years old, and they've had issues on the wind farm previously. Back in 2018 and 2017, they replaced they took off 87 of the blades and repaired them for, I assume, was leading edge erosion, from what it sounds like. So the OEM pulled the blades off, fixed the blades onshore, put the blades back on. So they have been on and off those turbines a good bit, doing blade maintenance. Again, another series of learning experiments, I guess, just because you don't know and what it's going to look like until you put it in service, and it's such a large quantity. Are we starting to get a little bit smarter? I mean, can we use this previous data that's happening on these wind farms that have aged 10 years to develop, when we develop new wind farms and new wind turbines? Are we taking that knowledge base and applying it to these newer wind turbines?
Definitely. And I mean, for a company, that's very important that they do that, because when you have your very first wind farm of a new kind of turbine, then you have to set aside a relatively large warranty provision. So you set aside a pool of money that is sitting there in case that there's a warranty claim. And the more risky that your technology is, the higher the percentage is that has to be set aside. And I think it's legally mandated that it's, actually a separate pool. It's not just that, it's notionally set aside, but you continue to spend the money on operational stuff. So the companies care about minimizing that amount of money because, it affects their balance sheet. And then they work hard to make sure that they can reduce that number moving forward. So they'll definitely be taking all of the learnings that they can, and any warranty claims that are made, or any major incidents that they have to do a root cause analysis for. That's going to filter through to not just that specific turbine, but through to everything, and it will include maintenance manuals and all those sorts of things. Sure. And do you think that they'll end up with more inspections? Now, this obviously is a semi big deal, right? So do you foresee that they're going to have to get back out in all the remaining 110 turbines and do inspections on them? Is that going to be forced upon them to do that? Is the insurance company going to force them to do that? I would expect that they would do that. Yes, I would do it. If I didn't know why a whole rotor fell off a turbine, then you're probably going to be, doing some sort of preemptive action in the rest of the farm. It doesn't mean that you have to shut the whole thing down, but you might be watching a bit closer.
Right. Agreed.
You might limit the conditions that it's operating in, or something, until you start to get some idea of what happened. But obviously, I mean, I'm imagining in my mind, and I obviously don't know what the cause was, but I'm imagining that there was some torque check that wasn't done on some bolts, or something like that. I think it's that seems to be the most likely thing to just see it happen to one. And after 10 years, that's not normally when you see failures, because it's a design problem or a manufacturing problem, like a serial thing, you see a lot right at the start, and then you'll see less throughout the main lifetime, and then towards the end of the lifetime you'll see more failures again. So I think they call it the bathtub curve, because it's a lot at the start and then dips down and then comes back up again. So we're right in the, in the nice part of the bathtub curve at 10 years. So you would be looking for what's something that happened to this turbine that didn't happen to everything else. And the obvious. Like the nicest problem that you would hope to find would be that they just forgot to do maintenance on that one year, but there's records of maintenance being done on all the other ones, so you're feeling safe. You always when you're doing a root cause analysis, you're always hoping there's like a couple of failure modes. It's like, oh, this would be very self-contained and certain and easy to remedy. So you're always kind of like hoping for those easy causes. It doesn't usually end up like that, not in the ones I've had experience with anyway, which is a shame. But
no, usually
but the
not.
fact that they're not freaking out more does suggest to me that they immediately had an idea that it was limited to this one turbine. Because if you've got a whole wind farm of 111 where the rotors might just start flying off,
well,
I mean, nobody is going to risk that happening. I think I read that their stock price dipped on this news significantly, like from one rotor falling off. Imagine a whole wind farm's rotors just start flying off willy-nilly. I mean, I'd sell my shares too.
No.
Yeah.
That would be a problem.
Yeah, so I think they've got an incentive to.
Yeah, the stock price had a temporary dip. It wasn't permanent. It came back up because I think everybody realized it's one turbine out of thousands. Everybody, calm down. Things happen. It's not all that bad. But I do think you do raise a good point, though, that from the safety side, they did consider it to be a real safety risk, and they didn't want anybody sailing close to the turbines if they had another one, because that would be a much more catastrophic incident, because no one was hurt when this rotor fell off. Big deal, right? But playing on the safety side, I think this is smart. They actually put perimeters around it, like basically no sail zones around a total of 8 wind farms, some in the UK, some in Germany and Denmark, of course, to prevent boats from traveling through there. And my first thought was, well, how big of a deal could that be? But some of these wind farms are big. The Anholt wind farm is 34 square miles, so that's a 34 square mile of ocean that you're no longer going to pass through. I guess that makes sense, though, Rosemary, doesn't it, to put some sort of safety boundary for the time being while you're trying to get to root cause analysis, just to play it safe for a little while? Yeah,
it does make sense. I'm actually surprised that how close can you normally sail to them? Because, I mean, on a land-based wind farm, you can't just go up and stand underneath a wind turbine that's operating. Even staff of the wind farm that are there to do maintenance, they shut it down before they approach it. You don't stand under it. That's definitely not going to. Even though the blades almost never fall off, you don't. So I'm surprised if they let just members of the public sail right up and underneath them. That sounds like a terrible idea to me.
No, I have seen pictures of boats traversing through the wind farms, and I've seen it in the United States off Block Island, which is the only real offshore wind farm. It's like 5 or 6 turbines. There are water cruises. You take boat cruises out to get you fairly close to the wind turbines. Not obviously you can't get on the wind turbine base, but like directly, fairly close. Maybe not directly underneath of it.
If it's not directly underneath it, I'm okay with that. Obviously, I'm not a sailor. I don't know how hard it is to navigate, but it seems to me like it would be complicated to, weave your way through a wind farm without going directly under a rotor. Obviously, like the huge offshore wind turbines, those like 10, 12 megawatt ones, there's a lot of space in between those. So, I think a
lot of space.
Well, they usually say like 5 or 6 diameters in between, and so that's like a kilometer and a half.
It's a lot of space. Yeah.
Yeah,
or roughly a mile, as we say. Okay. Yeah. So I think this makes sense, and hopefully they get to the RCA pretty quickly, and everybody can move on, because I think you're right. It's probably a one-off weird thing that happened with this particular turbine. Is it very, very, very likely, almost 0 chance that it's something endemic to the design. So that's good. So we're going to take a quick break here. After this quick break, we're going to have an interview with Harriet Green from Equinor. So stay tuned.
Ping Monitor is a continuous blade monitoring system which allows wind farm operators to stay ahead of maintenance. Wind techs can often hear damaged blades from the ground, but they can't continuously monitor all the turbines. They also can't calculate how bad the damage is or how fast it's propagating based on sound, but Ping can. Ping's acoustic system is being used on over 600 turbines worldwide. It allows operators to discover damage before it gets expensive and prioritize maintenance needs across their fleet. And it pays for itself the first time it identifies serious damage or saves you from doing an unnecessary visual inspection. Stop flying blind out there. Get Ping's ears on your turbines. Learn more at pingmonitor.co.
All right, Harriet, thanks for joining the Uptime podcast. This is going to be a really interesting interview. I've been wanting to talk with somebody who is actually working in offshore wind in the United States, but you've actually worked in the United States and in the UK. And maybe you want to just introduce yourself as your expertise, because you're an operations manager with Equinor on some really big projects in the United States.
Yeah, thanks, Alan. Lovely to be speaking to you. My name is Harriet Green. I'm the operations manager for Empire Wind and Beacon Wind, which are two projects we're developing off the east coast of the US. There's no actual projects in the water yet. So we're really in the preparation phase. So you'll also, hear us referred to as prepare for operations as part of the project phase of this development. So that's really about delivering everything we're going to need for the long-term operations. But a lot of those decisions actually have to be made now, and I think people don't necessarily appreciate how early some of the decisions get made that are going to impact the way we operate these projects for the next, 30 years. So that's really my role within the projects. And you're right, I've come from the UK. Currently living in New York, but my experience is actually from the UK offshore wind industry, where I've worked for almost a decade. So hopefully bringing some good experience over the Atlantic. So,
because as you mentioned, there's two big projects going on: Empire Wind and Beacon Wind, which are some of the larger projects going to be off the coast of New York, where you've moved to, obviously. What stages are those projects in today? How far along in the sort of regulatory application process are you?
Yeah, good question. So we've got two lease areas, which are each of those are split into two different project developments. So we've got Empire Wind 1 and Empire Wind 2. Both of those do have offshore take agreements with the state of New York. So that is really heading into the permitting phase. So we've submitted our COP. We are working hard towards Article 7. Beacon Wind, so again, split into two phases, Beacon Wind 1, Beacon Wind 2. We have an offtake agreement for Beacon Wind 1, and we're preparing some of those high-level permitting documents now. But Beacon Wind 2, we are still awaiting an offtake for the second project.
So what does Article 7 mean in terms of the phases that you have to go through? So I think I'm a citizen of the United States, so I kind of watch these projects just as a sideline. It's really hard to understand the stages of development that actually happen. And there's, I think, a general assumption in the United States that there's just a bid, an auction, that the site is purchased and wind turbines just start appearing in the water. That's really far from the case, correct?
Yeah, correct. These can actually be a very long time between bidding and winning a lease area to actually getting turbines in the water. And a lot of that is driven by the permitting processes in different countries, and they do vary wildly. In the US, you've got your federal permitting and your state permitting, which was definitely a complexity that I've grown to appreciate since being in the US. So where our projects are, once you've kind of got your offtake agreements, you've got your contracts for your different projects, you have to say how you are going to responsibly develop these projects, and that comes in the form of a construction and operations plan, which we have actually received for Empire Wind 1 and 2 on notice of intent from the US Department of the Interior in June last year, which is great. And what that really does is shows how we're going to be following all local, so state and federal environmental considerations, and we're going to be minimizing our impacts on these areas that we're building the projects, just to put it very simply.
Sure. And there must be a lot to that, because the coast of New York is a big sailing area, a big fishing area. and some of the beaches may be sensitive there too. And the turbines you're going to put out in the water, have you announced what kind of turbines you're going to put out there?
For Empire Wind, we have, yes. So it was quite highly anticipated, but we did make an announcement last year that we have selected Vestas turbines, the 15 megawatt geared turbines that will be the technology for our Empire Wind project. And we're still in the early phases of that process for Beacon Wind, so we don't know yet what we're going to have out in the water for Beacon Wind.
Sure. So a 15 megawatt turbine would be by far the largest turbine in the United States, wouldn't it?
It would, and I guess you can see in the press what other projects are announcing in terms of what suppliers and what size turbines they're going to use. But yes, these are definitely some of the largest.
Yeah. So it's a lot of engineering. There's a lot of planning, obviously, involved into getting such a large project even off the ground and even getting through the permitting process. So there's a lot of work there. And your previous experience was in the United Kingdom, where there has been much more onshore and offshore wind development, and very successfully, I should note. What are some of the things, because you have 10 years experience in the industry and mainly in the UK, what are some of those things you bring from the UK to the United States in terms of approaches, technical knowledge, problems that got solved? What are some of those things that help Equinor do these big projects off the United States?
So certainly for the areas that I'm responsible, one of the biggest things that we bring is probably the operational experience. And this is true across any industry. There's a lot you gain from having that feedback loop, from seeing the real-time, real-life operations and the product of what's been delivered, and identifying what maybe did work, what didn't work, what it actually looks like as an end product. Being able to feed that back into the early concept and design phases is really key. And we don't really have that opportunity to do that just within the US, because there's no existing operational assets to be able to take those lessons from. So that's definitely one thing I'd say we are bringing, both for operations and across the project team, really actually having examples, real life projects that we can draw from, bringing the experience. But otherwise, yeah, there's a lot we've learned, and we can see it's different from the way that regulations have developed. So in Europe, it did take some time for offshore wind specific regulations, and again, that is very country dependent. So there's a lot of development still ongoing, really. There's a history from offshore oil and gas and from onshore wind. A lot of the regulations and technical requirements, particularly around safety, that have drawn on other similar industries. You see a lot of influence from the aviation industry coming into the way that wind farms and offshore wind farms are developed and operated. And I think we'll see the same for the US, but we may have a slight advantage where, as they're being developed for the US, there are already experienced developers, operators, a lot of experience in the supply chain that can really help that development happen faster. So that maturity that we need to get to in terms of having proper governance for an industry, I think we'll get to that point in a much more informed way from bringing lessons from elsewhere, across the UK and Europe and other regions that have more developed offshore wind industries.
And you mentioned oil and gas, and New York has not had any offshore oil and gas. And so from New York's perspective, they're starting with a clean sheet. They really need to have expertise from people like you to help with the regulatory aspects, because everything is new. Is in Equinor, but Equinor also brings just a lot of experience in total, because they have so many projects worldwide. Does the local, state, and federal regulators, is that relationship meshing in a sense that they realize that they don't have a lot of experience in offshore wind? Why would they? That they need to draw from the experienced group of operators and installers that are located off their shorelines?
Yeah, I'm definitely seeing that there is an appreciation for that just in some of the forums that exist and some of the industry groups that are being engaged in those discussions. So we do see, from our other competitors and collaborators in the industry, that there is a lot of engagement as well with various authorities and within various key industry forums. So I think that's a real positive that we can see that is happening. And the IPF coming up, you look at what's on the agenda there. I think there's an incredible amount of collaboration across all parts of the industry. So I think there's a lot of optimism around how we can all work together to get to the point we need to.
Well, I would hope so, because we have a really short time frame. If you're part of the 30 gigawatts by 2030 effort, and your projects are kind of pushing towards 2030 just because of all the newness of this, I assume that's part of it. Just in the United States, it's a lot of it's so new. You're just trying to get the wind turbines, get the regulations straightened out, make sure everything's in place before you really get moving. So your time scale is getting compressed very rapidly. It seems like. But in the United States, there's a big drive for wind, like there is everywhere else, and that expertise is going to make a huge difference. And the United States, maybe being last to the party, pretty much on offshore wind, is probably going to take advantage of expertise from people like you, just because you have all the knowledge. And it's good that you've actually moved to the United States, because we need your knowledge to get this project done. So it's fantastic. And your background is as a mechanical engineer, right? You're a mechanical engineer by training. How much of your mechanical engineering training do you use every day in your operations role?
Yeah, that's a good question. Yeah, I did. I trained as an engineer, mechanical engineer, and that's actually how I first entered the industry. I was working in day-to-day operations and maintenance as a mechanical engineer. A lot of contract management, a lot of contractor engagement and support, but then a lot of back office technical support as well. So really regarding the long-term technical integrity, root cause analysis, looking at failure modes, maintenance engineering, how we can be more proactive in terms of the way that we look for and evaluate failures, monitor, so condition monitoring. So I actually used it quite a lot in previous roles. This role is more sort of project management. So I do also have qualifications in project management. So I'm more using those qualifications and experiences these days, but it definitely helps to have that on the ground experience, having worked on the assets. And it's not just turbines, it's substations as well, it's cables. We've got onshore and offshore assets. So again, having worked onshore and offshore, seen the challenges, not just from a technical perspective, but from a health and work environment perspective, from a safety perspective, when that all comes together during design and you're only looking at projects on paper, it's really helpful to have that context, to have physically been there and seen it, and to be able to translate what you're seeing on paper to practical considerations and challenges that you will find later if you get it wrong now. So yeah, to some extent, I don't use my mechanical engineering quite so much these days, but it definitely does help when we're doing technical due diligence of different supplier systems to still have that grounding in an engineering background.
Sure. Like you said, there's so much to a project that we don't really think about. You mentioned the undersea cables and the substations. Those are major parts of an offshore wind development that on onshore you don't really even think that much about, because it's relatively easy to go do those things. But installing a substation out in the water is not easy. Putting a bunch of cable underwater is not easy either. So you must have a combination of good personal skills, being able to deal with people and manage people, at the same time having your little mechanical engineering filter to know when things are going awry and when to say stop and when to say go. That's a unique combination. Is that just developed over time as an experience and just being around it?
Yeah, definitely. I've absorbed a lot of what I've learned since working in the industry. There's some things that I've taken on as extra study. I've spent a lot of time looking at, certain mechanical systems. Did a lot of work on gearboxes when you're having to work more with, gearbox problems, or just general understanding how to be better at maintaining and foreseeing problems. Main bearings, blades was a particular topic that I was very interested in and very deep into for quite some time. So I did have particular areas that I developed much more knowledge through more formal training on the job. But then others you pick up as you go along, particularly some of the operational challenges. You kind of see things from day to day, and you start to get an understanding of what's important, but also what's difficult, what needs improving. You just pick up as you go along, really, and then try as best you can to feed those lessons back.
Well, I think you're in an interesting space right now because you moved from the UK to New York, essentially where there is no offshore wind, and you bring this vast knowledge over to the United States. Thank you very much. But you're going to need a great number of employees to get the operation up and running, right? You do have to bring on all your support people, all your supply chain, all your procurement groups. It just seems like you have a massive task to do. What we can just kind of walk through on the we got to get people side, what that process looks like, and how you're going to be able to get turbines in the water in a couple of years.
Yeah, that's a very, very good question, and one that I think is being asked across the industry. Not just within Equinor. We will be directly employing people ourselves. We will also have a lot of suppliers that are delivering some of the key parts of our project that we will be relying on, and they will also need people to be able to deliver to the projects. So for us, what that largely means for the operations, a lot of construction type jobs, particularly onshore, are very transferable. So a lot of the building trades, a lot of the engineering will be very transferable from other industries. So I think we'll probably see a lot of workforce development that way. But when it comes to the operations, again, there will still be a lot of transferable skills. There's a lot of roles that won't really change. We will still need on-site security. We'll still need administrators, right down to things like, cleaners and building facilities management, which won't change. So we think those will be existing skills in the areas that we're building that we can draw from. The challenges come with the more specialized jobs. So more of your offshore technicians, where you do need a little bit more specialist understanding and knowledge of the particular systems and assets that we're going to be managing and maintaining. Control room operators, is a good example that's actually quite specialized. So really what we're trying to do at the moment is look at what that's going to mean for us. What does our organization need to look like to be able to run a wind farm? That we can definitely take the experience from our existing operations elsewhere. We know what kind of processes we need to follow, what sort of tasks are going to exist on a day-to-day basis. We know what the involvement needs to be from our back office support organization, such as finance, procurement, even legal support we might need when we're, writing and managing contracts. So we can gauge a lot of the tasks and a lot of the workforce needs that way. But then when it comes to really seeing what those jobs, what the existing competence and experience requirements are that we need to ask for when putting those jobs out to the market, that's where we're trying to be a little bit more careful and not just take a copy paste. When you're looking at education and qualifications, there is a slight difference. When you're looking at what it means to have apprenticeships and internships, again, they don't necessarily directly translate from what we see in the UK, from what we see in Norway. So we need to be careful that we're not putting unrealistic expectations onto these job roles that alienates the people that we're trying to target. So we are looking at local hiring. We are looking at particularly the communities that we're going to be embedded within and, creating a symbiosis with. So what we really want to do is complete all the groundwork, understand what the current context is for those areas. What are the barriers to entering the workforce? What are the challenges to diversity and inclusivity? to make sure that when we do write those job descriptions and define what we're going to ask for, we're making it as possible and accessible as we can for those groups to actually have these opportunities, to be able to apply for these opportunities. So that's where we're maybe not in too much of a rush. We don't want to rush to judgment on those and just copy paste from what we've done elsewhere. So that's really what our task is this year, is much more of a scoping phase, making sure we fully understand and listen to the local communities as well. There's a lot of engagement that we're doing to actually just hear what's being said and what the priorities are for some of these communities, to make sure that we're positioning ourselves in the best way possible.
Well, you're in a very diverse area of the United States. There's all kinds of talent really close to these offshore wind projects. I think finding people, you would think it'd be somewhat easy, but I think you nailed it on the head, actually, that finding those specific technical skills are going to be very difficult. And that's something that's going to have to be developed locally, because trying to find an offshore wind technician in the United States, that's just not really a job right now. Or very few people would have that job. So if you want to do some of the more technical things, I think it's going to have to be homegrown, which is great for the local community. So if you happen to live in the general vicinity of some of these wind projects, there's maybe a lot of opportunities there. I know the National Renewable Energy Laboratory just put out a report that said there's going to be somewhere between 12 and 50,000 new jobs just for these offshore wind projects along the east coast of the United States. That's a great opportunity, and some of these jobs are very high paying. I think one of they mentioned was basically construction jobs that are about $70,000 a year. That's a really good paying job for that type of work. So there seems like a huge potential and to get involved in offshore wind. And what kinds of things are Equinor going to bring to the table here? Are you talked about some of the training that needs to be done, or some of the local community colleges and some of the training institutes, particularly in New York, New Jersey, starting to ramp up and wanted to support these offshore wind projects? Or in the state, is the state of New York stepping into that too?
Yeah, there's lots of groups actually clamoring to be part of this transition. So we are seeing that from the SUNY and CUNY areas, also the different unions with, training through unions. So there's lots of players here that, will be very valuable to training and developing a workforce that's right for this industry. I think it's about just having a better understanding all round of what it's going to take. So for us, from an Equinor standpoint, we're wanting to, as I said, get it right from the ground up. So once we identify exactly what those jobs are going to look like, we'll be able to do a gap analysis as well. What do we think the base level of knowledge needs to be? What does the base level of training need to be? And then we can start to look at which organizations are offering that training. Are there enough organizations offering that training? Is there additional training we need to be offering ourselves in-house? Are there training providers we can work with to develop the right training that then fills those gaps between what we're seeing as already being available, what is already transferable from other industries, and maybe what we need to do just to get people that final step. And it's a big undertaking for people. It takes a lot of courage to pivot towards a new industry that there is no experience of, whether you are picking what subjects to study at school to get ready for a job in this industry, or whether you're going back to the workforce after a break and you want to try something new, or if you do have existing skills but you want to try a new industry. It takes quite a leap of faith to jump from something you're comfortable with and you're used to start in a new industry, regardless. But then particularly when it's an industry that is still undergoing such a significant development and maturation, it's going to take a lot for people to feel comfortable to do that, to take that leap. So I guess we just want to make sure that people understand the jobs that are going to be available at the end of that journey, that they're not, taking such a big risk if there's actually going to be an industry here for when they land, that they can actually find jobs within.
So basically, go online, Google it, Google Equinor, check out what job postings there are. I think that makes a lot of sense, because if you are interested in renewable energy, if you want to think about a possible career there, that's a great place to start, because Equinor is just one of many that are going to be along the eastern seaboard of the United States. There'll be a lot of opportunities coming up, and the well-paying jobs, they are professional positions. It's a good opportunity for a lot of younger people to get involved in renewable, and I think that's very admirable. And I hope everybody does take your advice and go online and check out those jobs and see what there is coming up, because there's going to be, like I said, up to 50,000 jobs in the surrounding community just for offshore wind, and that's fantastic. So, Harriet, I really appreciate your time, because I'm learning so much about these offshore projects, and you being an experienced offshore person it's fantastic. And we really thank you for coming on the show, and we'd love to have you back at any time. So, Harriet, thanks so much. Everybody check out Equinor, look for new jobs with Equinor, because the Beacon Wind and the Empire Wind are going to be great offshore products.
Thanks, Alan. Thanks for having me.
I've been doing a little bit of reading on aerodynamic airfoils and all these improvements that could be made. And the one I keep seeing pop up on Google searches and that sort of thing is this sort of seagull approach to wind turbines, or seagull approach to wind turbine blades, where I guess the seagull's got some sort of weird feather manipulation going on, and I've been trying to understand it, but maybe you can explain it to everybody, because I don't understand all the aspects to it.
I think it's nice that the seagulls are getting their time in the sun for now. It's not normally a bird that people are inspired by. Have you seen Finding Nemo? The film with the lost fish?
We're an American, so yes,
okay.
We've seen it many times.
They end up
yes.
in Australia, right? And there's seagulls in it, and all the other animals in the film like talk and have intelligent conversations and whatever, and all the seagulls say is mine, 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 and that's basically it. They're always just squabbling over hot chips, French fries, I think you would call them. So they don't like. They're like a step up from a pigeon, I guess, but only one. That would be most people's opinion in Australia of a seagull. So nice to see their time to shine. And this is a question that I get asked a lot. A lot of people come to me. I get approached by a lot of inventors. And one really common category of inventions is, I have this high lift airfoil. And we can improve, or they've read a paper about a high lift airfoil. Oh, they should use this in wind turbine blades. It improves lift by 10%, so you'll get 10% more power. And it definitely doesn't work like that. And it's a little bit complicated to explain why. So maybe this is an opportunity to try and do that.
The seagull has, if anybody's watched a seagull while they're sitting on the ocean and seeing their wings are pretty complex, right? There seems like there's a lot going on with the seagull. What part of the seagull are they trying to drag into the wind turbine blade design world?
I'm not 100% sure, to be honest. And it's one of those things, it reminds me a bit of the tubercle idea, or I've seen, which is the bumps on a killer whale's fin. And I've seen people say that they, designed a wind turbine that was inspired by hummingbirds, and that it's really trendy to say something is, biomimetic or inspired by nature. But I think one thing, like the test that I use when I'm assessing whether that's cool, because there's so many cool nature inspired inventions, like shark skin. The surface of shark skin is great for reducing skin friction drag, and like a honeycomb structure is an excellent lightweight structural core material. But you have to look at what nature is trying to achieve with its design, and do you need that in the thing that you're trying to use it for? So in the case of a seagull, like they're agile, they're changing direction a lot. They've got to do a lot of different things with their wings. But a wind turbine, at least a horizontal axis wind turbine, doesn't need to do a lot of things with its wings. It just does one thing. They spin around and they make they generate lift across the surface, and then that lift, because it's rotating around a central axis, the lift makes a torque that can drive a generator, and you get energy. And if you design your blade right, which every wind turbine that you can buy out there, all the major ones, they are designed right. They're very efficient. The angles, the aerodynamic flow, it's the same at any wind speed. They change the speed of the turbine so that it rotates faster in fast wind and slower in slow wind, and so you always have the same angle of attack all the way along the blade. The blade's twisted so that the angle of attack stays constant the whole way along, and it's always operating in nice, close to optimal conditions. So one of the benefits that this seagull wing design is supposed to have is excellent behavior around the stall angle. So post-stall behavior is better. It's got a higher lift coefficient, and they've got some advantages going through the stall point. But a horizontal axis wind turbine, a modern one, never operates anywhere near the stall angle. I mean, so you got a horrible, just terrible design if you're trying to operate anywhere near stall. What you're trying to do with the wind turbine blade is to operate at the maximum lift to drag coefficient. It's not the lift that you want to increase. It's you want a lot of lift and very little drag. So this device will almost certainly increase the drag at the same time as it's increasing the lift. So you're going to end up overall with something that's not as helpful as you might think if you were just looking at the lift. And I think that one aspect of it or one application that could be interesting is if you used it on a vertical axis wind turbine, because those are constantly going through the stall angle. The angle is changing, the angle of attack is changing as it rotates around. And so that has been a problem with vertical axis wind turbines in the past, is this dynamic stall where, you've got constantly changing and like violent turbulence happening along the blade. That was really difficult structurally for the blades to deal with. So I can see some potential for a device like this that has better stall behavior. It might be good to apply to a vertical axis wind turbine.
So doesn't it seem like the seagull is application into the wind turbine world is really complicated? To put essentially moving feathers on a wind turbine blade seems complicated. How would you even really implement the design?
I think that's probably maybe even the most significant thing. So if you accept that there is some theoretical benefit to a vertical axis wind turbine, and if you are keen to develop a vertical axis wind turbine for some reason, then this would be worth looking into. And I think the first problem that you would encounter would be, one, how to make it and attach it, but two, the major thing is it's going to, how long is it going to stay on there? Because anybody who's ever tried to put something flexible in or around a wind turbine blade discovers that those things just anything flexible breaks. That's just the reality of it. I mean, what a flag looks like after a year or so flapping around in the breeze, and it's so light, it's not doing anything. It doesn't have many loads on it, but just from that turbulence, that constant
every load. Right.
The constant flapping, they tear themselves apart, and I think you're definitely going to see the same thing on this blade. So, on a blade that has like seagull features. So I think that we're probably some way away from the material science being at the point where when they design a flag that lasts 20 years in the weather without deteriorating, that'll be the same time as we can see, we're ready to apply a flexible device to the outside of a wind turbine blade and think it's going to last long enough to, pay for itself to, through improved performance.
Yeah. So I think what you're saying, Rosemary, is maybe a good idea on paper, but implementing it is where engineering has to take place, and it's almost impossible to make that reality. And I want to talk to you today about a second thing I've seen, which is a heavy lift gyroscopic lifting device. And the reason I saw it was because it was based out of Australia. You're going to ask me where in Australia. I'm going to tell you I don't remember. But as you know, Australia makes a lot of heavy industry equipment, and they're lifting heavy objects because that's what Australians do, evidently. And I saw this really interesting thing from Verton, which is a sort of a gyroscopic lifting device such that when they're lifting wind turbines up, they obviously where you put a wind turbine up and put up wind turbine blades is pretty windy usually, that it prevents the load from spinning around in the wind. And I thought, oh, that's pretty cool. So have you seen this technology before?
Until you showed me, but I think it's cool, and I would love to see it in action. So anyone from Verton that's listening, get in touch and give me a demo, please. But it does seem to be solving a problem. And you're right that Australia, does love a big construction project. We're very, very good at that. And if you're looking for jobs in the renewable energy area in Australia, you're going to find yourself most likely working on construction or project management of construction. That was a problem that I ran into when I moved back here. And one of the large reasons why I started my own company was because I'm not so drawn to construction projects myself. I like the technology, the earlier stage, but it solves a problem because, at the moment you've got weather windows for construction. You can't, install it. You can't, haul your turbine blades or any of the big components. You can't haul them up if it's very, very windy. And I think we saw, didn't we cover probably a few months ago, somebody was installing an offshore turbine, and one of the blades just, fell off the crane as they were installing it, just crashed into the ship.
Oh,
yeah,
that's
I
right.
mean, that's what you're trying to.
Yes, that's
you're
right.
trying to avoid,
yes.
Because obviously the blades are designed to, catch the wind, and so if the wind is high, first of all, you got problems for your crane. Cranes don't like to operate in high wind conditions, but then even at lower wind speeds, you might catch the blade and have it just take off into the crane or somewhere that you didn't want. And so I think solutions to expand the window of wind speeds that you can install in, that's useful. I think it's a real choke point at the moment in Australia's energy transition. Is there's these constraints on construction, getting the construction projects done in time, and there's also some equipment shortages. It's hard to get the big cranes and stuff like that. So if you need it for less time because you've got less times when you won't be able to work because the wind is high, then I think that's really going to help, and also bring costs down if you don't need to have the crane for so many days.
Well, I was also wondering if this sort of technology, because it's using momentum essentially, rotation momentum, that they can rotate a wind turbine blade or a heavy load very slowly in a controlled way, because you'd either speed up or slow down the gyros inside. So it would want to conserve momentum. So it will rotate around. And I always wonder if you're hanging, 200 feet off the deck of in a nacelle, you're trying to bolt on a blade, that sort of mating the bolts to the hub gets really difficult. I don't even know how they line it up today. It seems like you would need this Verton machine to sort of control it enough where you could actually get the two to mate unless the winds are down. It seems that there's any sort of wind, it'd be really hard to do. So I'm not even sure how that's even accomplished today, but this seems like really cool technology. It seems like something I'm going to be using in the future.
And I've seen a few videos. There are some on YouTube, not so many, but there's a few videos of wind turbine installations, and usually they have got like a crew inside the hub waiting there for the blade to come, and they grab it. The last bit is them grabbing. I'm not saying that they're not like carrying the wind turbine, but they are guiding the last little bit of precision that's needed to get because there's a bunch of bolts that need to line up with a bunch of holes with not very big tolerances, and that is manpowered at the moment, and they must it must be really hard to do that with there's any wind at all. So I think this technology could help.
Has to be. Well, I think the other thing this technology gets rid of is the tagline thing, or so you have people hanging on ropes trying to pull the load around and hold it, like we see in a lot of different means of construction, where you got a couple of guys on the ground. If it's windy, they have some ropes and they're holding onto the load to make sure it doesn't rotate. That would go away. So from a safety standpoint, that would make a lot of sense. Get rid of people being directly around a very heavy load, particularly when it's windy. So it's a really cool technology. I thought I'd mention it to you because it's from Australia. So there you go. Well, they'll go check it out, and maybe they'll offer you to go over. Go visit it. Make one of your famous YouTube videos.
If I can go watch an installation.
Break the internet.
Yeah. No, that's cool. Thank you for showing me.
That would be really cool. So that's our program for today. Thank you for joining Uptime. Check us out on YouTube. And while you're there, go watch Engineering with Rosie. She has some really cool videos out. The last one with Glenn Ryan, which is fantastic. So you can see Glenn in person. And check us out on your favorite podcast platform, Apple, Spotify, Stitcher, Google, you name it. And so join us next week on the Uptime podcast.